Hello friend, back once again with Code Python and it's day 3. These two topics are very often been asked in interview. Well, let's start with the shallow copy first. So what shallow copy is all about? Well, I have written a code snippet, but let me comment this entire block so that we can see what happens when we execute an dictionary. So over here we have a dictionary, and the dictionary contains a key called name and a key called score, which also contain another list. So that's how the dictionary has been framed. We are dealing with the module called copy that comes up with Python, and this module will provide a very important function called copy. So copy.copy, the name of the function is copy, and here we are passing this dictionary. But before that, let me tell you one thing. I want to print the address of a dictionary, and for that reason I'm using the function called id. So with the help of the id function, I will be able to observe the address of any memory resource. So here I am checking the address of this particular dictionary, and then I gave a call to the copy function, and I created another reference called shallow, and I want to see the address of shallow as well. And after executing these two lines, I can come to the conclusion that both the addresses are different, isn't it? Yes. So once you create a copy of a dictionary, well, you can use another word, another synonym term of copy is like clone. You're making a clone of a dictionary. Both the resources will create its own memory location, or will use different memory locations. So as you can see, this is the address of the original, and this is for the shallow. So it's very clear that the address of both the resources are unique. Great. Now that brings us to another important question, that is, what about the internal resources that the dictionary contains? Remember, the dictionary contains a resource called name, another resource called source. How about their addresses? Are they same? What is the address? The address of name, the address of score will be same for both original as well as shallow. That is something what I want to conclude now, and for that reason these two print statement will show us that are they share a common address, or are the addresses are unique. Why am I talking about this? Why am I raising a concern about this? Well, there is a reason behind that, because we see the address of the key dictionary present inside the original has the address which is exactly the same in case of shallow as well, and the same goes with the list. The list with the key called score present in the dictionary called original, that address and the address of the newly created dictionary that is called shallow, both are same. So what conclusion can we draw from this? Well, if you think like this way, like this original is a dictionary, undoubtedly it's an outer resource, and these are inner resources. So we can say that when we give a call to the copy function, the outer resource will have its own address, like what we can see over here. Their addresses are unique. Whereas if the resources inside the dictionary, like for example this is a string resource, and we know the string is immutable, that means once you create a string you cannot remove the string. The string will be there in the memory, you cannot change it. And the same way the score is a list, which is again an object. In that case, if the resources of a dictionary has a string or an object, in that case the initial address will be same both in the original as well as in the copied object. That conclusion we can draw from this, right? With this conclusion, we come to a very important part of the story now, that what will happen if we bring some changes. Like for example, if I bring some change in context to original, suppose I want to change the name of the original from Alice to Bob, what would happen in that case? Similarly, if I want to bring a change at the 0th index of the list score present in the dictionary original from 85 to 100, now what would happen? Will the change take place? Of course change will take place, that's not the big deal. The deal is that what about the address? Will the change take place both in original as well as in shallow? or that won't take place. Well, for that reason we need to see something very interesting, and we have to understand very clearly. So we are going to modify two things over here. We are modifying the name, we are modifying the score. That means we are modifying the string, as well as we are modifying one of the particular index of a list present inside the dictionary, right? So after we have modified the, let me take this thing from here and let me put it over here, because here we are doing the modification. Yes, so let me just comment this portion for the time being. So we have modified the index 0 of the list score present in the dictionary original. That's what we have done it. And I want to see, will this change reflect, or will this change just restrict to original, or even the change will also allow to shallow? Is that what we are going to observe now? So let's go and check out. Yes, we see the change has really affected in both the dictionaries, both original and shallow has undergone the change. Okay, so after modifying the very data of the index of the list score present in the dictionary original, now what we can say is a real big change. That is, since the inner address was same both for original and for shallow, the change is now reflected in both the dictionaries. That is something interesting. So remember, when you're using the copy function, is basically it's a shallow copy. So when you are doing a shallow copy, the outer location, even now see, the outer location has got its own address. But if the inner key of a dictionary has a list, and if you modify the list, the modification will be reflected in both the original and the shallow copy reference. And that's what you are seeing, that the change has taken place in both the references. You can prevent this with the help of deep copy, but as of shallow copy is concerned, the change will be reflected in both the cases. So that was happening in case of a particular index being modified in a list present inside the dictionary. What if I go to change the string? First of all, remember one thing: when you're changing a string, the string itself is a mutable. I mean, it's an immutable one. So that means each time you bring a change, another memory reference will be utilized, right? In this case, there is a very twist in the story. So if I'm bringing the change to the name present in the original dictionary from Alice to Bob, will this change be reflected even in shallow as well? Think about this. Well, there are 2 points here. Firstly, we already saw that if I bring a change in one of the index of a list present in the dictionary, the change is getting reflected in both the resources, right? So if you think from that perspective, the answer would be yes, the change from Alice to Bob will be reflected in both cases. But hang on, you also need to remember one thing: a string is immutable. That means if you're changing, that would be a new creation. The previous stuff still remain in the memory. So what do I mean by that? Well, see yourself and figure out what I mean by that. And as the code gets executed, you see one thing. Okay, let me print the original also, otherwise you won't be able to see the. We can see over here the addresses are different. That means original has changed Alice to Bob, so that's the reason a new address gets generated, whereas in the case of shallow, it's still holding the same address. Look over here, the address which was there initially, Alice, that means the shallow is still holding Alice. And to better understand this, we need to print the value of both one more time, and then we will be able to figure out the difference, right? So let me copy this, and what I will do is that I will bring the line over here so that you get to see again, otherwise I have to rewrite again. Instead of that, I am putting over here. So now we will be able to see the difference. So here is the change taking place. So the value of original is this, value of shallow is this, and the address is this. So what I will do is that I will bring this over here, keep it this like this, no problem. Now let me clear the screen, let me run once again, and here it comes. And now you see the change has taken place only in context to the original, but shallow is still holding the previous string that is called Alice. That's the reason why you see the address of Alice over here, and here you are seeing the address of shallow over here. But in context to the index that we have just now did the change, that is reflected in both the cases. So after this particular video, what conclusion can you draw? There are some important points which you must remember. When you are creating a clone of an object in form of dictionary like this, certain important thing will happen. You need to see which particular method you are giving a call. If you're giving a call to the copy method, in that case this is a shallow copy. The shallow copy, what it does is the outer dictionary will have a different address and the shallow reference will have a different address. But if inside the dictionary we have a list, in that case the list will be shared among both the references. So if you're making a change in one of the reference, that change will be reflected in the other list, other reference as well. Exception is about the string, because since string itself has a feature called immutable, for that reason the change will be reflected only in the resource where you are doing, while the previous resource will still point to the address which was there before the change. And that's the reason why this particular program becomes a very important question for the interview purpose. Keep it in mind, whenever you work on Python, you will be coming across object in the form of dictionary that would have a list inside, or that might have another dictionary inside. So for that reason, when you are cloning such resources, you have to be extra careful. So this is what we saw in case of shallow copy. Now let's give a small look in context to deep copy, and here it comes. I have made a little bit of change in this particular program. Previously I was using a dictionary over here, and this time I am using a list within a list, because this is very common stuff, right? So that means at the 0 index of the list original, I have another list. At the 1 index, I have got another list, right? So let me just comment this thing and let me execute the initial two addresses to see whether they are same or not. Of course they won't be same, they are different. Here it comes, they are different, right? It's very obvious that initially they will not point to the same location, otherwise there is no meaning of writing the deep copy function. Always remember, copy or deep copy is coming from the module copy. Okay, so initially the outer reference will always hold a different address. The challenge comes when we are going to modify the inner resources, just like the way in the previous case I modified. So here also I'm doing the same thing. So I want to see the address of this inner dictionary, inner list. Is it same for both original and deep reference? Well, of course it would be. That's what we saw in case of shallow. Now I just want to ensure, will it be same in case of deep as well? Let's go and run, and this is a very important thing. Look over here, they are not same, and that's what brings the difference between copy.copy was close. So when you are using copy.copy, that's a shallow copy whereby the inner references will be holding the same address, but the moment you are going for deep copy, the clone will be different. That's the reason why original, which is the dictionary at the 0 index, the list that hold a different address, while the deep 0 index, that's another dictionary, another list that's hold another address. So that is a confirmation that in case of deep copy, inner as well as outer references will be having different address. Keep this thing in mind. So it's very obvious now when they are by default different. So if I bring a change in one of the reference, that change will be restricted within that resource only, while the other resource remain untouched, right? And that's what we are seeing right now. So if I did bring a change to this particular item 0, that means at 0 index, and then 0 at this item, if I change it to 100, that's what I'm doing in the deep reference. So of course that will be restricted to deep only. So the original will still point to 1 like what we see over here, and the deep is pointing to 100, which is very obvious. So after the end of this particular video, I believe it's crystal clear to you that whenever we work on a list or a dictionary, within that what resource you are holding, that is very important. And then You need to remember the module copy, which comes up with a method called deep copy and another method called copy, whereby we come across a topic called shallow and deep copy, and thereafter we understood how the cloning taking place. So from interview perspective, this is a really wonderful program. Please give a look, and I believe it will help you a lot. Okay, so see you soon. Bye bye.